Hi, Calculus. So today we are going to learn how to apply the Peterson diagram. Yes, I made it up myself. And of course I'm, egocentric, so I named it after myself as well. Anyways, this is really going to help us learn how to answer FRQs that pop up on the AP exam quite a bit. So go ahead and get your checklist ready, and we will do a little warm-up here to begin. Okay, I've got a lot of words on the screen, so in just a moment I'm going to need for you to pause, okay? So here's what I want you to do. After you pause, I want you to answer these 10 questions. You do not need to put them in full sentences, but if you will either put positive, negative, increasing, decreasing, concave up, or concave down, so just number your notebook 1 through 10, and then one of those 6 answers will be correct for each one. Of course, you can use them more than once if you so choose, but again, please, on numbers 1 through 10, put one of those answer options, okay? All right, I'm going to give you some time to pause and answer these, so go ahead and pause for me. Okay, hopefully you paused, and now we're ready to look at the answers. There they are, okay? So I'm going to ask that you pause one more time, and this is just kind of like a pre-check, so we're going to see like how much better we do after the lesson. So I'm going to have you pause one more time and correct any that you missed. Okay, we are back. So now what I want to do is show you the Peterson diagram. These types of questions pop up all the time on the AP exam. In fact, when we had those really long FRQs due to coronavirus, one out of the 2 was like entirely a graphical FRQ, and you could use Peterson diagram for all of it. So here is what I would like for you to write. Let me show you the Peterson diagram first, and then let me show you how it applies to these types of questions, okay? So here's what I'd like for you to write. So we're going to go kind of in order of what the second derivative gives us, and the first, and then the original function. So the second derivative, the sign of the second derivative tells you what about the original function? It tells you concavity, okay? So we're going to start the diagram putting, maybe not, we're going to put CU for concave up / CD for concave down, okay? And that's kind of the first slot, if you will. All right, now if I move over derivative number 1, f prime, the sign of it tells you what about f? It tells you the increasing, decreasing behavior, right? So if f prime is positive, f is increasing. If it's negative, f is decreasing. If f double prime is positive, f is concave up. If f double prime is negative, f is concave down, okay? And then, if I move over to just f, it's positive or negative, okay? So now let's apply this to some of our questions. All right, so let's start with question 3. I've got a little star by it so you know which one I'm looking at. It says if f is decreasing, then what is f prime, okay? So remember, every time I move to the right, I take a derivative. So some people even like to put a little like d dx, right? d dx. So let's answer question 3, and let me show you how to use this diagram. So it says f is decreasing. So I'm going to go to my decreasing slot right here and label it as f, okay? Now what I'm looking for is f prime, okay? So f prime is the derivative, so I need to move over one slot, right, and stay on the negative end, okay? So f prime would be here, okay? And I moved one to the right because I'm taking a derivative, right? So if f is decreasing, f prime is negative, which we got there. All right, let's try a couple more. All right, going on with number 4, if f double prime is negative, then what is f, okay? So I'm going to go to my negative slot and label it f double prime, okay? So here's my negative slot, f double prime, okay? Now notice every time I move to the right, I take a derivative. So if I move to the left, I'd be at f prime. I'd take a derivative away. That's called an antiderivative. And then if I move to the left one more time, I'd be at f, which is what I wanted here, right? I want to know what f is. So I would need to move 2 slots to the left to see what f is, and that would be here. I'm still sticking with the negative tail end of things, right? So when f double prime is negative, f is concave down. And so far, we've really only answered sort of these straightforward questions. You probably knew how to answer these, without the Peterson diagram. Notice that how I currently have it labeled would also work for number 5, right? Okay, let's try something like number 6. So number 6 says, if f is concave up, then what is f prime doing, okay? And this is kind of what we were talking about when we talked about inflection points and the spread of a virus. But let's label here. F is concave up. So I'm going to go to my concave up slot and label that F, okay? Now I want to know what f prime is doing. So I need to move to the right, take the derivative of f, 1 slot, and that would put me at increasing, okay? So when f is concave up, f prime is increasing. And by the way, f double prime would be positive. Now let's take a look at number 7. It says f prime is increasing, right? And we want to know what f double prime is. So that's what we're just doing. So I'm going to come to my increasing slot, label it f prime. I want to know what the second derivative is doing, so I need to move over 1 slot to the right. Okay, so f double prime would land here, so that must mean that f double prime is positive. All right, let's do a couple from the beginning as well. I'm going to start with number 1 here. So it says if f prime is positive, then what is f? Okay, f prime is positive. So I go to my positive slot, I label it f prime. Okay. We want to know what f is. Well, I would need to move backwards, right? I would need to go to the left, 1 slot here, and label that f. Okay, so when f prime is positive, f is increasing, right? Now let's take a look at number 2. Number 2 says f double prime is positive. What is f prime? Very similar to the one we just did, right? So I'm going to go to my positive slot and label it f double prime. Now I want to know what f single prime is, so I need to move backwards a slot. I need to go to the left 1 slot, still sticking with the positive piece of the slot, okay? So f prime would be increasing, all right? Okay, what I would like for you to do next is go look at the solutions, the video solutions for AP sets 3A and 3B, and this is really where this Peterson diagram is going to come into play.